Well, hello everyone. Welcome back for some more game dev. Let's see if I can build this thing. Let's also see if I have my to-do list here. Like so. Okay, so that succeeded. That's good. That's good. So I can play it. Hey. All right. Turn on the volume a little bit. Hi, Nirava. Welcome to the stream. Yes, so today we're going to do a little bit of physics work. Not even necessarily anything that's going to go into the game. We're going to work a little bit on the tech side today. I think we should be able to stay mostly on the Zig side of things. But we're going to have to expose a few things from C++ to Zig. And then when we have that, we should be able to do some breakable physics stuff. That's something that I haven't really done. Well, really ever. Oh, this is the wrong project. Opening the wrong project now. All right. Well, just let this load, and we can open the correct one. Yes. So, breakable physics. Not really sort of destruction within the object, but basically being able to build something out of multiple objects and then sort of destroying that. That's something that I haven't really done, at least with bases. And let's see if we can make that happen. Find your channel from the Zig Discord. Yes, that tends to be where people find me. I guess there aren't that many people doing game dev with Zig yet, and so that tends to be a pretty good place to find my streams. Or at least it seems like a lot of people are coming from over there. But anyway, welcome, glad to have you. Right, so basically what I'm thinking is, let's put in a new layer here. What do we call this? Breakable. Doesn't really necessarily matter all that much, because we're, like I said, we're not necessarily going to keep this, but this is kind of what I had in mind. So put in a primitive object here. We make this, what should we make it? 3.21. So like a plank. Let's make it a slightly larger plank. Something like this. If you have a physics object like this, which can be, let's duplicate that, move it to the side. We can make this slightly taller. Actually, we can make it 1, 1. So we have sort of like a solid base like this. What I want to achieve today, what I want to try to achieve today, is if we have sort of planks, you know, at least sort of conceptually fastened to this thing, like this, and let's rotate that way. I don't have a plan for this thing that I'm building here, just building something. You know, these things would be sort of connected with some sort of joint, probably like a fixed joint. And so, if you gave enough of an impact of a hit to some of these things, they would sort of come off. If we could make it so that I can build sort of like a setup like this somewhat easily, then that opens up a whole lot of opportunities for me to do things, build things that are sort of breakable in the game later on, if I want to. So let's try to make something like that happen today. Yeah, let's just load this. And so, oh, actually, we probably want to put in, yeah, we probably actually want to put in like a script that would allow us to load that thing, right? Can I actually load a layer from here? I don't think I can. Where's game state, maybe? Yeah, I can't really do that. I should really add a command there to actually load a layer. But what we can do instead is just go here to the base layer and put in a script. And then we'll just take that away and add a like load. Oh, that should be dev. And then the function would be something like load breakables. What was it called? Breakables. Right. Self load layer. Name and blocking. Sure, it can be blocking. That's fine. So basically, if we now run this script here, load breakables, we get this construction there. Let's put in like a mother vehicle. I forget how ridiculously large this thing is. But basically, we should be able to like either just like drive into it, or we should be able to like mess around with the crane and just break it that way. And we also need to sort of take into account like, okay, so which object is sort of connected to which, right? So we don't get the sort of Minecraft thing going where you cut the base of a tree and like the top of the tree is still left sort of hanging in the air, right? So if we take this guy and duplicate and move it off to the side. Oh, that's not what I wanted to do. I wanted to do this. Something like this. And duplicate that some more. And move this guy over here, right? So now we clearly have sort of like a hierarchy going. So now if you were to, nudge this thing, it would just fall off. If you were to nudge this thing, both of these guys would sort of fall off. And so on. So we need to model that somehow. Right. Does that make sense? I think it makes sense. So the way I was thinking about doing this was what? Well, what am I doing here? That's not what I want to do. Let's just bring this thing over. So if we Google for physics guide, I'm still on physics 4, so we'll use this one. And this guy has joints, and it has breakage. this thing. So something that I haven't really exposed to the engine so far, so we'll need to do that. And of course we'll need to do it all the way from physx, which is a C++ library, to Zig, so that the game code can call this thing. All the standard physics joints can be made breakable. A maximum breaking force and torque may be specified, and if the force torque required to maintain the joint constraint exceeds the threshold, the joint will break. So basically that thing. That should be simple enough to do. Hey Matt, what's up? Doing some physics joint breaking tests today. Taking a little bit of a break from the audio work. Actually, just keep that there. Gonna have to recreate these guys because this is not the correct sort of object type for this sort of thing. I did actually, so some of you may know that I've been doing audio work lately, and I am still working on that. We have a little bit of vehicle collision noise now, so now if you drive around, you can sort of perhaps hear some bumps and those kinds of sounds. Still working on the sort of overall object collision sounds, but they are actually not in yet. So if we just drop an object here, like a power cell, and it falls over, it's not going to make a sound currently. And if everything goes well today, we're going to be dropping lots of objects, but they still won't make any sound, unfortunately. So I have perhaps even all the code written for that. I just need to do a little bit of audio design to get that stuff sorted out so that they sound good, because they currently don't. But yeah, let's load the breakables. Where was the thing? So it's over there. So basically, should be able to nudge one of these guys, and it should come off if we hit it. If we hit it hard enough. I do have a storyline for the game. Yes, indeed. We have a storyline for the game, and the mission, this particular level that we're looking at here, this is the this probably somewhere in like the middle of the campaign. It's not the first level, but it is the level that's going to be the demo level. Is it just a basic hit then play sound at the moment? Right. Won't take into account the surface type and change the sound based off of that. It is currently all the stuff is in this Scout suspension sound effects. So it doesn't read the material, if that's what you're asking. No, you can look at it here. We have the suspension noise for the Scout. So this thing has an intensity parameter. Goes from it has 4 levels, so it goes from 0 to 3. Let's turn off the background music for a bit. And it kind of adjusts the noise based on that. So if you have intensity 0, this is a very sort of low noise, as you can hear. And if we put up the intensity to 1, it becomes ever so slightly more loud, and it also changes that, like, which sounds it actually uses. Put the intensity to full, the sounds are more sort of direct, maybe is the best word. But this is just noise coming from the suspension line. I do have a collision default event here. This is supposed to be sort of like if you don't have a material specified, or you're using the default material, it will use this, and it has sort of like the same thing going. So with intensity 0, it's like, and if we bump that all the way up, that sort of thing. So they're sort of like kind of metallic noises, because I'm assuming like most objects that are actually going to be hitting something here in this game are going to be metallic or metallic-like. And then we have these levels in between that are sort of it's like a little more mellow. But yeah, this is the one that I'm not super happy with. It doesn't sound very good. I need more levels, and in particular I need more sort of low impact noises. These high impact noises actually kind of work because you typically don't have like a whole lot of really high impact collisions going on, so sound kind of okay. Did I stream building Timbre and the game engine? Sort of. I haven't been streaming for very, very long. I've been streaming for probably a little over half a year or something like this. And I've been building this game engine for a very long time. So no, not all of it. But there are some pretty old videos on the channel. Some of them can go into how this stuff is built. But yeah, if you have any questions, just feel free to ask. Don't be afraid. Right. So let's start with the joint, maybe. Right. Actually, let's maybe not start with the joint. Let's start with something else. We need another way to specify. Or we need another thing. No, we need another system feature exposed to Zig if we're going to want to do this. So basically, what we have here is like we have a hierarchy of things. If this would be the base, right? That's the base. We can nest all these other things underneath that, like this. That doesn't mean in bases they don't actually inherit their parents' transforms. So even though these guys are nested underneath this guy, if you move it, it still only moves the one object. So the hierarchies here are essentially only for organizational purposes here in the editor. But what I was thinking was that if we create a new kind of object, and we call this like, base, that would be like a static object probably, so that this whole thing stays upright. And then we have like object 0, and then this would be object 1, and object 1 would be nested underneath object 0, like this, and then this would be object 2, like that. So we could make the system so that if you have this sort of hierarchy here, the fixed joints that you can then break with enough force, they're always built from the child towards the parent. So sort of starting from here to here to here to here. So that would mean that if we broke the joint between these two guys, then all of these three would sort of fall over, right? And that's what we want to achieve here. And so I think this is a pretty nice way to actually represent that. If we just create a new component that we add to these guys, which is like, if you have this component, then create a fixed joint towards your parent, essentially. And to be able to do that, we need the Zig code to be able to figure out its parent in this hierarchy here. And that's something that actually isn't exposed to Zig yet. Partly because it's kind of seldom used. It's used by a few things in the C++ on the C++ side. Like for example, that's probably locked, so I can't select it. But we have this camera path here. So this is the camera path for the intro animation, and this position path thing here figures out that okay, all of my children are going to form sort of like a spline, right? So if we take this guy and just move it, you can see the spline following along, and so on. If we move this, it will regenerate the spline and all of that. So it's used in a few places like this in the editor, but actually the Zig code doesn't know how to query that, doesn't know how to get its own parent, or children for that matter, but the parent is the more relevant object for doing this sort of thing. So I'm thinking we'll start with that, and we'll see where that takes us. So if we go to the C++ side, we can go to game object component, I think. Let's see if we can find it here. Oh, actually it's not game object component, it is editor component. That one. So this is a component that you don't add to your types, but instead every object gets an editor component added to it automatically. You can see here editor component, we click the info, we can see here down in the log that it is of type basis editor component, so that's this guy here. And this thing does things like it allows you to hide the component in the editor if you want to. You can lock it so you can't like click this thing, accidentally select it. And the editor component contains the functionality for getting the parent game object. This is the one that we need. And then for getting the children. You can do it in some other ways as well, but that is basically the easiest way to do it. So we just get the editor component, because there will always be an editor component in the editor. Looking at your game engine is really intriguing. Well, thank you. I see quite a few components in your UI. Is all of it handwritten? I'm not sure what you mean by components. You mean these UI views here? I use just like a whole bunch of different third-party UI tools to make this thing. So if that is what you mean, then no. This is just standard WinForms. This is a WinForms application, this editor here. So no, there's nothing super special about it, and it is actually written in C#. This editor. So yeah, it's not C++. The runtime, the core engine runtime is C++. And this editor actually runs the game in a sort of special editor mode. That's how we get all of these things sort of rendered here. And of course this editor functionality that you have here, which allows you to move things around, for example. That is of course C++, because it is literally running the game to show us these things. Huh. And I'm doing something that's really slow. What am I doing? Oh, I'm recreating some areas. Yeah, okay. That's stupid. Yeah, it's difficult to see because it's printing the same thing all the time, but it is basically recreating like a, I don't know how many hundreds of objects we just moved. Some of them are areas. Yeah. Okay, well, it doesn't really matter. Let's actually unload the backend for this thing. So now we have just the editor application running here. You can see that the engine is unloaded. We can click this to reload it, but I'm not going to do that. Instead, I'm going to leave it unloaded, and that means that we can make changes to the C++ side. So another thing that I was going to do, I was planning that I would do today. Let's collapse some of these things so we have some better idea of where we are. Components. So because there's no inheritance in Zig, you can't do the thing that you do in C++, where if we have like a, we have this editor component here derived from GameObject component and gets a lot of its functionality through that. You can't do that in Zig, so instead we have these things called contexts, GameObject contexts. GameObject component is one, and you use it by quite simply, let's look at some component like here, for example. This is a component, it's a struct, and it just has, as a member, it has a GameObject component. Through the context you can do all kinds of things. And I was thinking, this, where is the, what was I thinking of showing here? Maybe we'll do something like this. This should probably have a context transform, yes. Right, so if we want to get the physics actor, for example, we need to do like a, okay, self context, and then some of the stuff in the context are grouped into like sub objects like this. So transform is just basically a small wrapper. Transform API is the type, and it just kind of forwards certain things to the context. If we want to get the physics actor, for example, it's down here. I was thinking we would add another one of these sub objects beside the transform API. So I'm going to do that first, actually. And let's just copy basically this guy. Actually, let's copy the entire thing. Move it below this and then remove almost all of it. Let's leave the init there, and we'll call this editor API. Right? Because what we actually want to achieve here is we want to be able to get the parent object in the hierarchy in the editor. So basically in here. But you're not supposed to really try to do that at runtime, because the hierarchy is no longer there. It's just a flattened list of objects. So the functions that we actually only want the user to call in the editor will put under this editor API. And I actually have another one of these guys, another function in the context that you're only ever supposed to call in the editor, and it's this flush exposed properties. And we are going to move that into the editor API, because you're only ever supposed to call that in the editor. So we can just, I don't have a self there apparently, but we can do it like this. That's that. We can find it here as well. Let's remove that. Does your engine work on Linux? I don't know actually. I have built it on Linux and I have run it on Linux, but that was many years ago. It does build and run on the Mac, but I don't think my web GPU rendering backend currently builds on Linux. So I'd say probably no, but it might work with like 1 week of fixing up. Hey, I know this is unrelated, but if you're making a game, add ambient occlusions. Well, I have ambient occlusions. I have both dynamic and pre-baked ambient occlusions, so I do have them. All right. Right now we want to do something like this. We want to do editor API, and we want to just add editor API init and cpp ptr. Initialize it the same way as we do the transform API, and we do the same for this other. So I have two of these contexts currently. Editor API, move them there. Now if we try to build this, it won't build, because we are calling this flush exposed properties, and what we want to do here is quite simply call self.context.editor.flush exposed properties. So that's nice, because now it actually complains that, oh, you're calling this oh, did I not do that correctly? I have it here, so what's the problem? Oh, right. That's the problem. Yeah, I typically use, I have a sort of a, maybe I should just do that. Let's do the same thing here in these APIs. So I forward declare this as self, and then I use that as this pointer. I know Loris doesn't want us to do this, but I feel like this is nice, because it makes it very clear that, okay, we're referring to ourselves in this way. Like that. So self with a small s, and then the type is self with a large S. And that's nicer. All right, so that succeeded. That's nice. And now we can just, when we add this get parent game object, we can just add it here in the editor API next to this flush exposed properties, and it will be in the right place, so to speak. So let's go and do that now. And for that to work, we need to bind it. We need to bind it using my binding system. My binding system, which looks like this, it's a whole mess, and it gives, especially here in the beginning, until it gives up, it gives me like 100 or 200 errors here, because this is using C++ syntax highlighting, but this is not actually C++. This is just an interface. It's a completely made up language, which kind of looks like C++, I guess, so that's why I'm using the highlighting for it. But basically what we want here is a way to get the C++ pointer to the parent game object. Let's see, what was it called? Was it called just get parent game object? Yes. So we'll use that as well. And yeah, you have to jump through some hoops to be able to bind Zig to C++. You have to jump through some hoops to bind anything to C++, really. And so I basically generate this code because it's quite simply the easiest thing to do compared to some other magical systems. Right, so the nice thing here is that, what was the call that I did? I can now just copy paste this guy, this line that we created for ourselves here. And I can paste it here, and this becomes a C function. And C functions can be called from Zig, as I'm sure you are aware. For now, we'll just return 0 here, like so. I need to add this here to this list as well. So we'll get back to the C++ side in a little bit. At this point, we need to restart the CLS server. Did it restart? I hope it did. Probably did. And now if we write get parent game object, I'm using the self here. Game object PTR is a type that I use to represent as a C++ game object pointer on the Zig side. So it's a type that wraps like a raw C++ pointer. So we can do TPP PTR basis bindings. FP stands for function pointers, and now we can do component context get parent game object. So this line here was auto-generated for us based on that script that I ran there earlier. And now we can do game object PTR. I probably just need to actually initialize it like this. CPP pointer. There we go. Should take that away and make it a bit more compact. So this thing might return a 0 value, as it currently does. And that means that when we assign this value here to the CPP pointer inside the game object pointer class, well, this is then null. As you can see, we have a null checker here. If this was completely Zig, there was no C++ involved in this, we could just use optionals. To some extent, we can use optionals, but these types that kind of just wrap a C++ pointer, such as this here, they also handle null values if that value happens to be null. What is this game? This game is called Traction Point, and it's a vehicular puzzle exploration game that I'm building. You'll see more of it in a little bit. We need to fill in some blanks here in the code to get to today's physics fun. All right, so now we have the editor API. We have these two guys here. This is basically all we need to do now on the Zig side to get this parent game object here, but we still need to get that parent game object on the C++ side. And yeah, this is not at all as fun to do. Let's see if we use the editor component for something. We don't seem to do that. Okay, do we use the level data for something? Because we can also yeah, we use it there. That's not really gonna help us. Okay, well, I'm probably just going to have to use the editor component for this. So basis editor component. That is the guy that is going to be able to tell us the parent, the parent game object for this guy. Yeah, so basically what I'm doing here is I'm seeing how we actually get those components for the other calls. Editor component. This is the thing that we want to get, and then there's a macro. This is kind of convoluted, and this again has to do with the fact that we're calling C++ from Zig. We don't have all the type information that we would normally have. But here we can do get component, if I can type, and we'll do editor component, which we will give it as a template argument, and the return value is stored in editor comp. Right. Game object component has no member get component. Oh, right. Yeah, that's actually not what we want. We want to get the game object first. Game object obj is null pointer, and then what we actually want to do here is we want to call get game object like that, and we want to store the value in obj. Yes, that's what we want to do. And then actually what now we can do editor comp is equal to obj get component editor component like that. And so of course we don't need that line there at all. That's what we want to do. And now if we have an editor component, we can ask it, hey, what is your game object parent? So editor component get parent game object. Right. And then quite simply we do a reinterpret cast, because Zig doesn't know anything about C++ pointers, so it treats it just as a numeric value. This should be everything we need to do. So we get the actual sort of, not like parent, but the game object that this component belongs to. We check if we have an editor component for it, and that means that if we're calling this at runtime, when there is no editor component, this won't crash. It will just return a null pointer. But hopefully, since we added the new editor API there, it should be kind of obvious to everyone that if we're calling this at runtime, then stuff is not going to work. So if we have an editor component, we get a parent, which of course again might be 0. This might be a null pointer, in which case this is just 0. But we return that to Zig. That should be fine. I never put on the background music, so let's do that. Right, that built. That's cool. So, now that we have this working, and I know I haven't tested it currently, but we'll do it in a little bit. Now that we have this working, maybe we'll do the physx joint next. So we have basis joint physx. I have sort of my own physics API, which can be used with various different physics engines. This game is using physx as the actual physics engine, so we are only concerned with that right now. And so here we can set the breakage. What was it called? Let's have a look. set break force, right? Let's actually go into the physics side here and see something like that maybe. Actually no, it's probably jumped somewhere weird. PX joint. Set break force. So this function is what we want to actually expose to Zig and to the C++, to our own C++ physics API as well. We'll just copy that guy, put it in here. Like so. PX real, that's just a float, and float like so. And so now basically we want to put this in all the same places that we have this enable projection. They're both pure virtual functions. Yes, so it's these places. I'm just gonna quickly put it in all of these classes. The fact that I have to do it in every single class is shows that this API is perhaps not the most elegant, for being completely honest here. Hello, time zone, or timeless. Welcome, welcome. So if we have, let's see, yeah, this is now the interesting thing here. Ah, damn, I don't remember this is how it actually works. So physics, when you actually add a joint to the scene in physics, you actually just create the joint like this. That's not how my physics API works. You can create the joint beforehand and then you can just add it to the scene. And that's why we have this, like when we're enabling projection, we check, do we have a physics joint? So basically, has this joint already been added to the scene, sort of from like the physics perspective? If we do that, then we enable projection, so we set some stuff there on the actual joint. If not, we skip it, and then when we add it to the scene, we read this projection enabled. So like regardless if you enable it first and then add it to the scene, or you add it to the scene first and then enable it, it will work. So we'll probably have to actually do the same thing here. Yeah. This is a little annoying. Okay, well, let's implement it for the fixed joint, because that's what we are interested in today. And I'm just going to copy this function to the other one so that we can actually build this thing. Distance of 6, and I think there's still, let's see, enable projection is there. There's still the spherical spring joint, which is actually not a joint type in physics. It's created using a DOF6 joint. Just call me timeless. All right, I will. Right, so now this should build. I'm hoping. Let's see. And it does. That's good. And so basically what we need to have here is, let's see, bool m break force enabled. And we'll call this, that's going to be a float actually, break force, and float break torque. Right. Let's put this next to the header file there. Yeah. Break force enabled will default that to false. Like so. And here we need to do the same thing then. So we set break force enabled to true. Break force is force. Break torque is torque. And if we have the fixed joint, that means that we can call it on that guy. So break force, force, and torque. Otherwise we just store them here, and here we check if break force enabled, then bx fixed joint set break force, and that would be m break force and m break torque. If that makes sense. Which I think it does. So now we have it kind of working on the C++ level. So basis joint, this is the thing that, or I guess technically that, this class is the thing that we will actually get access to on the C++ side. But you can see that these guys typically don't have anything. The DOF6 joint and yeah, and well, basically just the DOF6 joint has some additional stuff. So this is the interface, and this method is the method that the game programmer gets access to. So now we need to somehow expose that to Zig. And we can do that very simply by doing the exact same thing we did previously. Class bindings, let's find like this enable projection, for example. It's right there. So we'll just do void set break force. We need the uint pointer t, cpppptr, and then we need float force and float torque, like so. Again, we can copy that guy. And then we run the little batch file here, which generates some code for us. And if we go to, I think it is Zig interop, or is it Zig physics bindings? Yes. Yes, it is. Set projection, is it? Or enable projection was the name. Projection. Again, we'll put it right under that guy. Oh, we need the joint type as well. Yeah. Okay. We need the joint type so that we can do the correct casting here. See, the joint type here is a uint32 parameter. So we'll copy it there, redo the generation. And now we can put it there. And get some errors here because we need to actually put this thing in the list for the bound functions or methods or whatever. So if joint set break force, force and torque, and this break force is now the thing that we actually goes down to this guy here. So that's good. All right. And again, this should build. And if this now builds, then with a little bit of luck, we don't really have to go into C++ anymore today. Let's stay on the Zig side. Registration name is used for when you actually make game object types out of things, which I will show you in just a little bit. Let's just let's add this method to the joint type here in Zig, and then I can show you. So here's enable projection. Again, let's mimic the type here. So we'll do set break force self const self, and we have force. That's an F32, and we have torque. It's also an F32. It's a void. So now I think it probably won't show up. So if we try to do physics joint set break, yeah, there's nothing there. But if we do restart ZLS, we wait maybe 5 seconds. Look at that. Now it's magically there. So yeah, it looks like CLS doesn't pick up on that generated stuff that we had my binding system generate for us. Like so. Okay, so now we have the whole break force thing dealt with. Yeah, the registration name is basically, you don't create objects in this game engine like you do in Unity, for example, where you create a game object and then you can just start slapping game component components on it in the editor. That's not really how it works. Instead, you have this this game object types list here. So these are all the types that we have created. So a bunch of like cliffs and trees, and we have the vehicles here, things like this. And you can just, if you want to place something in the level, you can select the parent here. If you want to put it next to the or under the breakables layer, for example, you make that the highlighted parent. You just select a tree and then you place it there like this. And the components that this tree now has, you can see that it has an editor component, a transform, a trunk mesh, and a branch mesh. This list comes from the game object type. The game object type is set up here in the asset browser. So you can search for something called a blueprint, not to be confused with like Unreal Engine blueprints, for example. That's not the same thing. But what should we look at? Maybe we'll look at the environment stuff. So we have the trees here, for example. And here is the list of components that go into this guy. If we want to add a new one, we can just add a component here, and the registered components are shown here, and these are the registration names. So a game object can have a mix of C++ and Zig components working together in harmony. And you can add a component that you don't register with this application, which means that it won't be able to show it here. You can still use it as long as the runtime knows what it is, and it knows what it is based on the registration name. But for example, if you have a mesh component here and you want to be able to set these properties here called blueprint properties, then you need to actually register the type here with this asset browser. So we have the mesh here for the leaves, for example, and we can exchange that to something else, like a cog. This might I guess break the thing completely, but there you have a cog with a leaf material, so not a very successful thing, but you get the idea. Maybe we'll just revert that thing. So that's what the registration name is for, because these types are sort of data driven. And then you can still, like, if you want to have, let's say, put a parcel there, you can still in many cases actually override these things here in the like override the material, for example, for this parcel here. We can make it like a block out blue, for example, and you get a blue material there if you want to. So there are some things that you can do directly here in the editor if you really want to do that, but everything still comes from a game object type. So we're defining the blueprint for a component so that you can control things from the engine. Well, the blueprints are created here. Not sure I follow exactly what you mean, but the blueprints are done here. You can use this just without the engine, or you can attach like an instance to this, which makes it easier to see what is going on. Here's the oh, that's the gripper actually, but we have the scout vehicle here, for example. Yeah, it doesn't have any wheels in this thing, but you can just create a new blueprint here and call it vehicles, some new vehicle, like this. And this is actually now, well, we have a transform component here, so now we can start to add a mesh to this, for example. It's a mesh, rock collection, and material, I don't know, block out brick. So there we have our beautiful bricks. We can add another mesh if we want to. Mesh component. Tree trunk. Green. It's a very weird tree. But yeah, this is the blueprint now. This is it literally. You can add, remove, and you can move these components up and down. So that's it basically. And you can see here also the creation policy. The game engine is a client server engine. So that is how it handles networking. For example, if you want to do a multiplayer game or anything like that. But even if you don't do that, even if you're just making a single player game, it still uses a client server model. And you can see here that a mesh component, for example, actually you can't add a mesh component to the server. That doesn't make any sense. So you can toggle it here where you actually want to create it on the client, and that basically means in the game. If you want it to show up in the level editor, you can toggle it here, and asset browser preview, that's this thing here. So if we toggle this off and save it, you can see that it goes away, because this is the asset browser preview. So I hope that answered your question. If not, then just let me know. I'll try to answer as best I can. Anyway, we can leave the asset browser open. I'm gonna shut down the game there because we might do some changes again to the code. And yes, you can run both C++ and Zig code right here in the engine. Right here in the editor or the asset browser. The creation policy specifies where that component is created, and you can do basically anything that you want. Well, within some certain limits, I guess. But you can, for example, have your components updated in the editor just the same way as they are in the game. Which means that you can, for example, have these things physics simulated. Just take a few of these guys. We can select them and toggle this, and we can actually drop these guys, and they behave just like they behave in the game. And then if you're happy with it, you can go, ah, that's nice. And then you can undo it and redo it, and everything works. The blueprint basically mainly used for assets. The blueprint is used for anything that you want to dynamically instantiate in the game. So for example, when you create a game, that game typically has something called a game master. The game master is the first game object that is created, and it controls things such as when is the game over, that sort of thing. If you have like a game mode, let's say you have a capture the flag and a deathmatch multiplayer game. You might have a capture the flag game master and a deathmatch game master, and it would then put the sort of the game rules there, if that makes sense. So it doesn't have any assets in the sense that it doesn't have any meshes or physics. It doesn't even necessarily have a transform, but it's still a game object, and that means that it will have a blueprint. So here you can see you have a game master base. So these blueprints or these game object types can derive from other blueprint types, and so we have 4 components on this guy, and then the actual game masters are, we have a default one, which you can see it derives from gameplay game master base, so it's this guy here, and then it has a means game master component. I don't even actually remember what the game master component does. Game master component, yeah, it spawns the player avatar basically, so it spawns the vehicle. If you don't have a vehicle for the player, this guy goes in and spawns one for you. We can see here that it spawns the vehicle slash scout game object type, which is the car that we've seen. So yeah, this is just a normal component. Nothing special about it, other than the fact that this belongs to the gameplay slash default game master type, which is the first game object that is created. And then we have a separate one for the campaign game master. So if you're playing the single player campaign, we have a campaign game master component, and this probably does something slightly differently. Commented out the spawning logic for now. Yeah, campaign has specific vehicles that are used as avatars. So it quite simply has this commented out. But yeah, it has all of these things that are more important. So they are indeed used. Right. Okay. Let's go back to the issue at hand. Basically, what I wanted to do now is add a component that allows us to make something like this. Build this kind of hierarchy. And we'll see if that works out. So we now have, I think, the 2 things that we needed there on the tech side to be able to do this. We can set break forces on the joints, and we can get the parent object. All right. So let's unload this guy once again. I'm going to add a new component, and I think I'm going to add it to one of my helper libraries. So we have GHL, which stands for Game Helper Library, and VHL, which stands for Vehicle Helper Library. This would go into the GHL version. We don't actually have any components in GHL, so we'll probably want to add a folder here called components. I do have components here on the VHL side. Typically what I do is I have this sort of, what do you call this, like a barrel module or something that takes all the components that we have. Currently on the VHL side we have 3: auto gearbox, vehicle controller and vehicle wheel renderer. It just takes them all here and puts them into a list like this. And then this list contains all of the components that this library exposes. So let's do that. Let's make a components.zig file, and we'll immediately create the component that we actually want to concentrate on today, and that would be called fixed joint component.zig. And I have a handy little snippet for creating one of these guys. So fixed joint component, and typically what I do here is I add means dot. So means is sort of the project name for this game, even though it's called Traction Point these days. That's the actual title of it. It's called means, and that's why this project up here, which contains the game code, is actually called means as well. Although now I'm doing things wrong, because this is not in means, this is in GHL, so we'll call it GHL dot fixed joint component, of course. My bad. Right. I don't think we'll be sending any messages to it, so let's comment those out. We can do the same thing with that one. We don't necessarily want to tick or update either, but we'll see, maybe. And I think that the rest is probably fine. So now we'll go into components and we'll do pub const. We'll import that guy. Oh, import fixed joint component dot fixed joint component. We'll just shorten it here like this, and then we'll make like a similar kind of list that we have here. Fixed joint component. So far we have only, come on, we have only one of them, like so. But if we then have more of them, we can just add it to this list, and that will be fine. So for the actual build process to now pick up on this, we still have to register this component with the system somehow. And that can be done in means. So here we have, it's probably somewhere here, isn't it? Yes. So we have a master list of all the components that we actually use in this game. We have the means ones, we have the VHL ones, we have the timbre ones, and the Merlin ones. Merlin is that's a particle system runtime, and I'm gonna slightly wonder about, don't we have any components on the basis side? But maybe we don't actually. We probably don't have any basis components in Zig. They're all C++, so that's why it's not here. But we can just do ++, and then we can do DHL dot. Oh, we don't. Yeah, one more thing is missing. We need to do basically like this thing, right? Just that line. We need to actually expose the components from GHL. Yeah, it's just smack there in the middle of everything. Let's just put it like so. So now if we go back here to this, we should be able to do ghl.components.list. I see you had some auto-generated methods that you just commented out, so I presume the component would extend an interface that allows your engine to interact with the component itself. Sort of, yes, sort of. Of course, Zig doesn't have any interfaces. You're right in that if I uncomment this guy now, this thing will get updated. Well, every application update essentially. So there's the variable update. Tick is the fixed update. I think Unity has something similar where it has like update and then like fixed update or whatever. And yeah, if you have them here, they get called, but it's not like an interface except on sort of like a philosophical level, because there are no interfaces in Zig. However, what actually happens is, if we look at update in string form, all the components are created through something called a component factory, which does a whole bunch of things at compile time to figure out information about your components. So because Zig has excellent compile time support for things, we can do things like this, where we assign a has update with this at hasDecl for an update. You can see pre-tick, here's the tick one that we just looked at previously, and there are some other things as well. And then this has update can be used here when we actually update the factory. We can just look at if this thing actually has an update. Then we go in and we update the components. And so the idea here is that if you have a game which has, you know, I don't know, 20,000 components, and by components I mean like component instances, and updating all of them is kind of wasteful, or at least it's not necessarily wasteful, but it's slow. But if you have 20,000 components, then maybe you have 200 types of components, and each component type gets its own factory, so you can quite easily update 200 factories, and then the factory decides, oh, do I actually need to do anything? And if this has update is false here, then this whole method essentially just goes away. Especially with like the higher sort of optimization levels. So that's the idea. But yeah, the snippet that I have just happens to include the update and tick. There's some other things that you can do as well, like the message on message received, for example, can be used to receive messages. Unsurprisingly. Okay. Cool. Let's do a very quick test now. I'm gonna make it print. Let's see. What? Editor. Yeah, that we don't want to save that. I made some stupid change there. If I can remember how I actually editor communications manager is what it's called. This thing has some static methods here. Yeah, print info. And I think we have the same thing in... Yeah, it's called editor. Okay. Print info. So basis.editor.printinfo. Cool. So this is how we can actually print things in this editor log here. So if we have this fixed joint component, if I do here in this create function, so we have an init. If you've read any sort of idiomatic Zig, then you'll probably see these init functions here. We have the same thing here in basis for these components. This is where you can actually initialize the fields of this component, but the self pointer is not stable yet, and this engine requires self pointer to be stable for a whole bunch of different things to be set up. which is why you have a separate create function here, where you can sort of depend on this self pointer here being stable. And here we can do self.context.inEditor. So if we are in the editor, we want to get the parent object, right? So this is the thing that we just added previously. So we can do self.context editor get parent game object. And if not parent object is null, then let's get the name out of the, let's call it like something like parent name, get name, and then we can print that, right? So basis editor print info. Oh, this takes an allocator. Okay, that's fine. We'll just give it the allocator for the context. It's not code that's going to hang around anyway. My parent is something like that. Yeah, the snippet is a little bit old. I should add the auto ignore comment there to make CLS take that away automatically. Right, so now if we create one of these guys in the editor and they have a parent, they should print in the log what their parent's name is. Isn't that cool? Let's see if that works. So for that to actually work, we need to make a blueprint for ourselves. So let's make a blueprint here. I'm going to put it in the development section here because I think I'm not going to keep this around for very long. I just mainly want to use this as a test for the new tech that we're building today. So let's do like a breakable object. And this breakable object has a transform component. If we want to make this a dynamic object, which we probably want to do, then we want to get rid of the transform component and add in a dynamic object, dynamic body transform component instead. And here we can set if this is supposed to be a box, a sphere, or whatever it is supposed to be. Let's just keep it as a box for now. We can even model a quick mesh for it in Blender later if we want to. So we haven't registered this fixed joint component with the asset browser, which is why it won't actually show up here if I type this, but we can just paste it in there anyway. And then it's going to complain that I don't know what this is. We can just go, yeah. Trust me, bro, it's fine. And I think we actually want the fixed joint only on the server. So the transform is created on all of them. The fixed joint is only going to be created on the server. But we'll create it on client for now because we want it in the editor as well. So let's do that and we'll tap that as well. That should be good. Okay. Can just minimize that. And this is now built. So let's go back to the editor and see what we have. And if we just create an object here under the breakables, so we should, first of all, we should find it here now. Here we have the breakable object. It doesn't have a mesh yet. It just shows this Lego piece here. Just create one of these guys. We see successfully generated blah blah blah. It doesn't really have any parent, but let's make this guy the active parent. And now if we create this, we're still not seeing any parent stuff. Okay, that's unfortunate. . 'Cause Did I do something wrong here? Let's see. If we are in the editor, get the parent. I wonder if the parent is... the parent is sure to be set at this point, right? I'm pretty sure it is. Actually, yeah, we can just do right here. Put an else here. And just print like no parent. Yeah, and I need to unload this once again, otherwise it won't let me rebuild this thing because the DLL is in use. Yep. Okay, let's see. So breakable object, let's add it there once again. No parent, and that makes sense. There's no parent. This layer doesn't count. It's not an object. It's just a layer. Fixed joint is right here. It doesn't have any properties here, but we will actually add that in a second. But we can see here, okay, component name fixed joint, type is GHL, fixed joint component. It's created on the client server and level editor. So now if we add that, set that as the active parent, and we add this, we still get no parent. Okay, so that might be because the parent hasn't been set yet at that point, which is a little annoying, but it's not the end of the world, because we actually won't be using that data when we create this guy. So let's just actually move this somewhere better. And I think now would be a good time to actually start adding those properties to the component. For that, I typically use this expose property test component, which we briefly looked at earlier when we actually moved the flush exposed properties somewhere else. So you can do all sorts of things. You can add these exposed properties to a component, which makes them show up there in the inspector, property inspector in the editor. What is going on with my keyboard now? There we go. So pubconst exposed property map, and there's a map of things that we want to have there. So as a very first thing, I'm going to add a button, and it wants print parent, that's the ID, print parent. Yes, we have an action name and a button text. These show up in different places in the UI. In the UI of the editor. This print parent is the action ID. So whenever this button is pressed, we will call editor button action executed, and we'll get the action there from the editor back, and then we can try to print the parent. So let's do that. It will be print parent like this. I will take basically all of that and just stuff it in here instead. Uncomment it. We don't need to check for is in editor because this function only gets called if we are in the editor. So let's see if that works. again, let's make that the parent, and we just add a object there. So now we have this print parent button here. If we click this guy, no parent. Now if we nest it under one of these guys, yeah, we still don't have a parent. Okay, that's interesting. So maybe we did something wrong. Maybe I did something wrong rather when doing this thing. It's entirely possible. So let's maybe try to attach this thing to the editor. I wonder if I should do it here, or if I should do it in Visual Studio proper. I'm thinking probably this, because I bet the problem is here probably. So let's do. That's not actually where I want to be. It's Zig interop, right? Somewhere here. Yeah, it's right there. This thing. So we want to get a breakpoint there. All right, so now we just need to attach this to the exe. We'll see what happens. So now if I press the button, we should hit the breakpoint. Print parent. There we go. Do we have an editor component? Yes. Have an editor component. Oh, I don't return it. There we go. That's the problem. Yeah, that probably fixes all of these strange things that we've been seeing here. Unload that. I'm just missing a return there. There we go. And then just rebuild. All right, we're pretty close to getting to the cool physics stuff. Just a little bit longer. So now then, breakable object, print parent, I have no parent. Now my parent is breakable's primitive object, primitive geometry object 7. There we go. And now we can make like a really deep hierarchy, and we should see my parent is breakable's primitive object 8, 9, 7. So it's 8, 9, 7. That's the name of the parent. Cool. Okay, so now that works. It probably would have worked in the create as well, but it doesn't really matter because we're not really interested in it there. Instead, we are most likely interested in it when we export the level. So we want to put in like a custom data export step for the object, because it's not supposed to create any joints here in the editor. It's supposed to create the joint when it has been created. And because it always creates a joint to its parent, like this guy would create a joint to this guy, which would create a joint to this guy, which would create a joint to that guy. And since by definition parents are always created before their children in this engine, that should always work. It should always be possible to do, unless someone has like specifically deleted an object and then sort of in a deferred fashion loaded a child. Then I guess it is in theory possible. But it needs to handle that as well. Okay, cool. So now we should actually be kind of close to having cool things happen, because what we can do now is we can set whether or not we should create a fixed joint to the parent. We can set the break forces here. And then in, I guess in onObject created maybe, or in create, one of these guys, we'll create the joint to the parent. So So the difference between create and onObject created is that create is called when this component has been created. OnObject created is when all of the components of this object have been created. I guess we can do with just create now. I think that should be fine. So let's put in some exposed properties for ourselves here. So create joint to parent, this would be a Boolean. Breakable joint, it's also a Boolean. Break force is a float. Maybe we should initialize that to something larger, but we can also initialize it there in the exposed property map. Break torque is also a float. Yeah, I think that's basically all that we need. We don't need this button anymore, the button can go away. What we want instead is a property. So that's always self, and that's self with a small s. Field name. So create joint to parent. We need to tell it the compile time value here, the default value. It's kind of unfortunate that Zig forces me to initialize these values here or in the init. Because I need to give them here in this property one as well, so that you can then set them back to the default value from the UI. But oh well, it is what it is. Yeah, and we can just basically copy paste that. That's also a Boolean. Then we have break force, break torque. Here we can set these to some kind of sensible values. I don't know, 10,000 or 1,000. That's cool. So now we can make it so that these break force and break torque values only show up if this breakable joint is set to true. And it can be done with another one of these special functions that get run. So it was break force and break torque. So if the name is break force or break torque, then we only show it if breakable joint is true. That's cool. Okay. Okay, that's good. Let's do a little bit of cleanup and just remove all the things that we don't need here. Like so. Right, so I spoke earlier about the fact that I wanted to put in a custom export step. So in this engine, components can write arbitrary binary data to the level file if they want to. That can be very handy. And that is done by adding a method or a function called export level, which looks like this. And basically this component, which is an interaction area component, it writes some data there to the level, and then it can read it at runtime. And that's very handy. So let's do the same thing here. We don't need to write all that much in this case, but we want to write the name of the parent. Because, like I said, the hierarchy is not available at runtime. Actually, it's only available in the editor. So we want to make sure that you write that there if you actually want to create a joint. So the way this works is that you create a data block. You need to give it a unique name, so it's kind of handy to just use the component's own name because it's guaranteed to be unique. And then you create a buffer size. This is sort of like the maximum size that you want to write. So it allocates a temp buffer for that, but it will only write as many bytes that you actually write to the data block. I think for now we will quite simply write the parent name here. So let's see. I want to basically do the same thing we did previously. Parent self context editor parent game object, and then we have parent name is this is probably like if parent. Why don't I get any? I don't get any help from ZLS now for some reason, but okay then. If parent is not null, then we do parent get name, else we just have an empty string. Right? And then to the data block we add a chunk. Yeah, strings are sort of, they're a little tricky. But what I actually can do here, which is even better than writing a string, is do const parent name hash. Let's copy that because CLS wasn't helping me very much. Parent get name hash. That's just a string hash. And it's a 0 if you don't have a parent. So that's cool. And then we'll just write basis string hash, which is quite simply a 32-bit integer, so it's very small, which is nice. And that should be it. This phase thing is just like you can run this in phases if you want to. If you just don't want that, you just use the first phase to export things. That is if you have like a bunch of objects of the same type and you need them to sort of interleave their data, then you can export in various phases. Okay, cool. So that should be good. Now I think we can read it if we are not on the editor. Yes, exactly like that. So here in create, if let's see, we do const data block manager is self context get game session get level data get data block manager. It's a little bit of pointer chasing there. Could maybe be handled in a nicer way. And here we can do get data block, and the name is self context get name, right? That's what we used. Yes. And try get chunk. Yeah. Or get chunk, I guess. It should always be there, but yeah, let's just get the chunk. So we have var parent name hash. This would be a basis string hash, and we initialize it to 0. So we do index 0 because we just added a single chunk there in the export level. This is the type. And then we have address of parent name hash. So that's good. Now we can do if... Actually, we can do another condition here before this. If create joint to parent. If and only if we do that, do we actually need to read that stuff out of there, right? So maybe we'll add another function here. This can be a private function. Create joint to parent. Self and parent name hash. Yeah. Oh, void, of course. Parent name hash. See if this builds. Ah, it does not. What do we have? Duplicate stuff, create joint to parent. Huh? Really? Oh, right, it's... Yeah, okay. Right. Okay. What do we call this then? Do create joint to parent. Oh, yeah, these are supposed to be smaller s's. Like so. Oh no, they're actually not. These are supposed to be, yeah, this is supposed to be the type of property, of course. So F32 and F32. All right, so now it succeeds. Cool. Okay. Let's search for create fixed joint. In particular, I want the transforms to be sort of the inverse, I think. Magnet joint. Yeah, magnet joint should be kind of good. Shouldn't it? So basically I'm trying to remember here how was it that if you just want to fix two objects sort of in the world frame, or if in without moving them, want to fix two objects together with a fixed joint, the actual position doesn't, I guess, really matter all that much, but see, magnet world local transform. This is like a magnet for a crane that I can use to lift vehicles. We specify the hit point in each of the object's local spaces to fix them to each other. Using the inverses to object's orientation makes the joint take the current relative rotations into account. Yes. Okay, so that's basically exactly what we want. The magnet is the transform A, and the target is the transform B. Oh, magnet world to local. Yeah, okay. So we can use basically like origin here. So vector 0 for the position essentially, and then just the inverse of the rotation. I think that should actually make it so that you just fix things to each other without trying to sort of force them into some specific pose. So that's cool. How do we now do this? How do we create the joint? The first thing we need to do is figure out, do we actually have this parent? Is this parent thing actually a thing? We're now at runtime. This is how we can get it in the editor, but now we need to figure out the parent from this name hash. So we can do parent self context get game state get game object by name hash, parent name hash. So if parent is this is actually an optional now. Cool. So if parent p, I guess. I mean, the parent can still be null because this is a pointer to something on the C++ side, but I think I made it so that this returns, it returns a null here if the object is actually a null object. We don't need to check for that anymore. Oh, hey Tutu. Nice of you to join. Is the code open source? No, not yet, at least. Unfortunately. Right, so we have P. If we don't have this, then we quite simply can't create this guy. So we should probably let the user know that they've done something wrong. And we can do that by doing basis debug overlay debug warning. Cannot create fixed joint to parent. No parent object or something. I mean, we could print this hash, but it doesn't really help the user all that much. So maybe not. Right, so now if we have the parent, then we need to get the physics actor out of the parent. So let's do const physics actor. First of all, the our own physics actor. And then we need to get parent physics actor. That would be p get physics actor. So they're essentially the rigid bodies here. Unless you throw something on like something really weird, like a character, and then we'll get the character controller there, which is the physics actor. But we don't have any character controllers in this game, at least not yet. So that should be fine. And I guess technically we could go like if actor type is, and then it would need to be like a dynamic or static. Oh yeah, triggers. Triggers are also actors. But let's for now say that the user of this component isn't doing anything silly like that, so we can just use these guys. And now then, maybe we should call these actor A and actor B, like so. Oh, come on. Sometimes VS Codes, or I guess CLSS, autofix things get sort of in the way a little bit, and they mess up my edits. All right, so we have actor A and actor B. It shouldn't really be any sort of any sort of direction between this anymore. We just want to create a fixed joint in these two guys' local space, essentially. So let's just do that then. Let's do. I think we'll probably need to do. We want to have the joint here. This would be a basis physics physics joint pointer. And this is such a long thing to write, so let's shorten it a little bit to just physics joint pointer. And initialize it to null, and we'll probably also want to get the scene, right? So basis physics scene pointer, like so. Just take that guy and put it there. We need to get the pointer to the scene so that we can actually add it to the scene. And that can be done here. Scene is self context get primary physics scene. It's called primary physics scene because you can technically, at least on the C++ side, you can just create more scenes if you really want to. I don't think I've really exposed that to Zig yet. To be honest, I've never really used it for anything. But that is why it's called primary physics scene, because it's the scene that gets created for you. You do have two though. You have the client and the server, so there are two of them. But you get the client scene by calling primary physics scene on the client and vice versa. Okay, cool. Now we can do joint equals self context. Is it physics engine? Yes. Create a fixed joint. Maybe we want some more space here. So we have the actor pointer and we have the physics transform. Okay. So we want to do something like actor A transform get world transform. That gives us a physics transform. Actor A joint transform. That would be basis physics transform init, and vector 3.0 I think is what we want to use here, and I'm not 100% sure about this, but I think that should work. So it goes from the center of one object to the center of the other object, essentially. And the actor A transform inverse, or its orientation dot inverse. That's what we want to use for the actual rotation for actor A. And then let's just copy that and do the B version. And now we quite simply have actor A and actor A joint transform, and we have actor B and actor B transform, actor B joint transform, like so. And we can do if self breakable joint. Then we do self joint set break force, and self break torque. And then we can do self scene add joint self.joint. And that's it. That should be all we need. We still need to remove it though, but that's a whole other question. That's actually a pretty good question, because what if the parent gets destroyed before or let's just say, what if either of these actors get destroyed before the joint? That's something that's probably not very good. I tell you that much. Anyway, if the objects are just put into the scene and then the scene is unloaded, it should unload the objects in the reverse order. So for now, let's do if self joint. So if this is not null, remove the joint, and self joint release and 0. I think that should cover the most obvious cases, at least. Let's go, just to be sure, let's go into game state.cpp. I think there's a function here called destroy all game objects. Yeah, that doesn't necessarily look like it's doing them in reverse order. I must be thinking of something else. Okay, that's annoying. Well, what we can do is listen to a message, and immediately when the game is to be unloaded, we do destroy the joint. That will handle the cases where you quite simply load into a level, create these hierarchies that we have now been thinking about, and then you unload the level. It should fix that, at least. And that message is called game ended, I think. Yeah. Yeah. I'm just gonna drag that off to the side so that I can copy it out of there. So we actually ended up needing this on message received after all. Engine messages, yeah, that's just basis engine messages, like so. Right, here we can quite simply just do this. But let's actually add a function for this. So fn destroy joint self void. Put that there, and we can just call self destroy joint, and we can also call self destroy joint here if this guy gets created or destroyed before the game actually ends. And then for this message to actually be sent to this object, we need to subscribe to the message category which is that. Okay, cool stuff. Should we maybe try to build something with these things now. See if this actually works. So I'm thinking that we will probably want to put some visuals onto these objects. Let's just quickly go into Blender and model something. I'm going to put literally 0 effort into this thing. Let's delete the cube so that we can create a new cube, because that is the law when you're modeling in Blender. Scale Y probably. Let's make like a plank of some sort. Like a plank. What are the dimensions of this? It's really quite a small plank still. Let's make it like 1.5 meter. Oh, not the Z, but the it's actually I'm getting confused with these coordinate systems. Actually, it's quite large. Let's just make it 3. X is 0.5. Z is 0.1. Right? Because we need to match the physics size, obviously, to this. So that's a pretty good plank. We can call it plank, and then we'll probably duplicate that guy and make this into a slightly larger thing. Let's make it 5 meters long and make it into sort of like a beam or boom or whatever it's called. 0.3 and 0.3. Is that a beam or a boom? I think it's a beam. Beam. I don't know, do I even want to save this? Maybe I do. Let's put it in minigame object prototypes. I guess this can be like a dynamic props thing. What do we call this? Plank and beam. Plank and beam. Wonderful. Okay. Right. So we'll export that to FBX. And that should be called plank. Oh, actually, before I do that, I need to do the I need to apply all the transform all transforms. There we go. And that guy needs to be moved to the center as well. And then we do the same thing there. All right. Oh, it should probably actually have gone into gone into a work folder. So let's create one more folder here. Underscore work. And that is where I need to save that thing. Save as plank and beam. Blend. Yeah, it's important to be consistent with your standards. Let's beam. Like that. Right, so we should already have gotten some resource paths here, which we did. Plank bin mesh and beam bin mesh. Connecting vehicles together with joints. No, I'm testing out something. And you'll see in a little bit what it is. Let's see if this thing actually... Yeah, I didn't have any of those breakable objects here. That's good. We can get rid of those. Maybe we can leave the bottom one. It's that one. Because it'll be useful to actually have have a static object here. Just need to make sure that it's set as the physics blocker, because that means that it will have a physics actor. Or will it though? Actually, it doesn't necessarily. Yeah, it doesn't necessarily do. Yeah, primitive geometry objects are weird. Primitive geometry objects, or primitive geometry components in that sense, are weird. There's a create physics body thing here, and it creates just a very standard physics body, but it has a standard transform. Print here, it's just a basis transform component. This guy by definition doesn't have a physics body associated with it. So that's going to be a problem for us. Yeah, we can't actually use this guy. Let's just get rid of them, and instead I will add an object for us here to play with. How did you make the manipulation gizmos? With sweat and tears and lots of looking up math, to be honest. They are development. Static beam. Yeah, they're completely self-made. It's just an object that I move around, and the object is scaled with the camera so that it stays the same distance, same size on the screen, and it's also rendered on top of everything. But it's basically just like an object in the scene. Right, so here we want to have a static beam now, so let's put in a static body transform component. And we can actually open a preview here so we can see what's going on. We'll do a mesh. And this mesh is not a dynamic mesh. It basically means that it can participate in like light mapping and things like that. Not really interesting for this particular object type, but yeah, we can have it there anyway. Reload company. Blah, blah, blah. Yeah, I want this beam to be there. Yeah. It's unhappy with me because this mesh is empty here, so that's why it doesn't work. Block out. Let's make that like a gray one, like so. You can connect that again and it should show up. Right, so this is something that we can now sort of anchor everything to, because this is a static object. So that's nice. And the size was, what was it? It was 0.3 and 5. Is that correct? Yes, that looks correct. Physics material doesn't really matter necessarily. If we make it default ground, then we can technically draw him on it, which I guess maybe handy. And then we can duplicate this guy and make it a dynamic beam. And I'm just gonna delete that and add a dynamic one there instead. Dynamic body transform component, and we need to actually move that up like so. The size is wrong again. Right, you're asking about the gizmos, yeah. Yeah, I think they're probably their own mesh. I think I have I have one arrow, and I think even these sort of planes here are their own mesh. And then for the rotation, I have like one ring, and then for the scaling I have probably like one of these axes is probably a mesh. I think that's how it works. Yeah. But yeah, they are literally drawn the same way everything else in this scene is drawn. There's a scale formula which I can look up for you if you're interested, but it's not super tricky to actually get these things to show up. I think even if we turn on like normals, and then yeah, it's super slow because we're drawing normals for everything in the whole scene now. But you can see that we're even drawing normals for the gizmo here. So yeah, it's a little stupid. And if we're drawing, it's super slow. We're drawing the axis aligned bounding boxes. We're also drawing axis aligned bounding boxes for the gizmo. Yay! That looks kind of fun. It's like a carousel of some sort. And yeah, picking isn't super tricky. The trick to doing picking when you're scaling these guys is to transform the pick ray into their own coordinate system, right? So like if we do like this, now the gizmo is really large, but the math is exactly the same because you are not picking in world space. I mean, you are picking in world space. You get the world space array from your mouse. But the first thing you do is you transform that into the local space of this gizmo. And if you're doing it with just a standard transform matrix, then it takes the scale into account as well. So then the actual sort of determining, you know, which one of these rings you are hitting, or if you're hitting one of these arrows or these planes, it's just exactly the same regardless of what the scale of the gizmo is. So it's not tricky in that sense. But yeah, I honestly don't exactly remember how it works because I haven't touched the gizmo code in probably 5 years or so. So oh yeah, if you do make gizmos, add this feature. This feature is awesome. You can see, I'm gonna use the gamepad for this. Make it so that it can sort of turn toward you like this. That makes it much easier to actually hit these guys and move things around. Turn off the AABBs here. I have a feature here in flip translate gizmo axis. So if you don't do it, this is what it looks like. So if you want it to not rotate, it looks like this. But then it can be tricky to go like, okay, I want the Z-axis now. So instead, you have it so that it always flips toward you, like this. That's nicer. At least I feel like it's much easier to hit them. And that, of course, can just be done with a simple dot product. You just take the dot off the vector to your camera and the dot in which direction this mesh is pointing, and then if they are not pointing in, or if the dot product is negative, then you flip it. It tries to point towards you. Okay, right. I was doing something. I was doing this dynamic beam. So we have the static beam is gray. Let's make the dynamic beam be another color so that we can actually see it. Which one should it be? It can be like red, maybe. That's a little annoying. It's an annoying red. Let's do it. Let's do brick Brick is like an easier to look at red, or brown, or orange, or whatever that is. And then we'll do the... Oh, we probably need to give this some sensible mass. This is actually kind of large now, so let's make it like 500 kilos. It's not kinematic. This is actually a dynamic mesh, so let's just toggle it as such. Blocks nav mesh, yeah, I guess it does. I guess it blocks the nav mesh. Okay, let's duplicate that and do dynamic plank. And we'll just simply change that to the plank version. Plank. And what was it? It was 1.1 and 3, I think. Nope. 0.5. Yes. Oh, don't feel sorry for. Usually, what I tell people when I'm streaming, it's fair game to ask me questions and disturb me in air quotes. If I do something super important that I need my peace and quiet, then I'm not going to be streaming, so no problem. For picking, you really use the bounding boxes instead of the arrows and planes, right? No, I think I actually do. I think I do picking like on a per pixel level. Maybe I don't. Yeah, it kind of looks like I don't. Actually, yeah, I wouldn't do that for these arrows. At least you're quite right, because they would be kind of difficult to hit. Yeah. Yeah, so it's probably done against some sort of bounding box, but it looks like it's not quite the bounding box of the renderer. AABB. I don't think it's that one. No, you can clearly see that it's not that one, like, because those are the axis aligned bounding boxes. So I think I have just a custom pick box. Should we have a look? Let's see if we can find the thing. Translate gizmo is the one with the arrows. Right. Okay. So I think I found it already. Oh Jesus, this code. Oh, look at this. Don't write code like this, people. Anyway, yeah, so I have some bounds. I have AABBs. So I have axis bounds in local space for X, Y, and Z. And I have plane bound local space for all the planes. So there's X, Y, X, Z, and Y, Z. And then I bet if we look using this for example, we can find like an intersection test. Yes, so in mouse moved. All right, so here you have the whole thing. I can make this a little larger for you. Here you have the whole thing. We get a ray from the editor camera, from the mouse position on the screen. So this ray will contain a position and a direction. And then you do the thing that I spoke about previously, where you want the ray in the gizmo local space, right? So we have world to local. You just take the origin and the direction, get it into local space. So this handles the scaling and all of that. And then after that, you use that gizmo local space to check, you know, did we hit X, Y, or Z? Or did we hit the center, right? You can always... oh, I don't think... Do I have a center on this one? No, I don't have a center on that one. I have a center on the scale one, but I don't think I have one here. Well, don't know what this is actually. Oh, we are in the scale gizmo now, that's why. Yeah, it uses the same names. Translate gizmo is actually the... This is the thing that I was looking at, but the math is exactly the same, as you can see. So yeah, we just check here if we actually hit one of these guys, and then I get like a distance out of it. Right, yes. So I get a distance that is initialized to the, like, this is like float max basically. Because you might be hitting multiple of these, right? If you're doing this, and then you're hovering, like here, you can hit this arrow. But now if you move it up, then you're actually hitting this this plane, this blue thing here. So we're hitting technically like both this red arrow and this blue plane here. So now we just determine which one of them is closer to the camera. And then I guess, yeah, we get the minimum from that, and then I do like a horrible if-else thing here, and I set the highlighted part. What does this do? Yeah, it just switches the material. Yeah. Yeah. Yep, it's it's not pretty code. It kind of works, but there's some edge cases that aren't handled all that nicely. Yeah, my number one tip for doing things like this is that, like, whenever something is like, oh, how the hell do I do this? How do I get this collision calculated? It's so confusing to me. Just like see if you can transform it into some other space. Quite often the math just gets infinitely easier if you transform it into like local space of one of your things that you're working with. Then everything is just super easy. Or not super easy necessarily, but easier. A lot easier. Okay. So if we go back to the thing, we have this guy here. This guy is now, there's really nothing very special about this guy, but this guy is here so that we have something to actually connect these two guys to. And these two guys now need that new component that we created. Right, so that's 500. Maybe that shouldn't be quite 500. Let's make that 250 mass. But I think that's basically what we need. Yeah. So the mesh is on the client, and it's dynamic. Transform is on both. And the new component will be created only on the server. So fixed joint, and we do yeah, trust me bro. Let's put it only on the server for now. We should quite easily see if it is actually if it is fixed, because it's not moving. It's that simple. Yes. I need to look into how collisions and raycasting works. That's all new, but I get how it works. Okay, good. Good. Yeah, no worries. Glad to help out. Yeah, and don't go believing that just because someone like me has worked in games for a while that I feel like this math is simple. That's not how it goes. I get very confused by math all of the time. Cool. So now, with a little bit of luck, we should be able to build some funky structures out of this thing. Let's start with just seeing if we can make like a couple of these guys stand up from... we can get rid of that guy. We established that we can't actually use it for anything. Let's go to development. We have our beautiful thumbnails here. So this is the spawn point for the car. So we'll put a static beam there. Just move it up. It's sitting inside of the grass. I have a static beam here. Maybe we'll move it off to the side a little bit so that it's not actually inside the grass. And then we need to make this the active parent. Let's do another beam. I'm gonna move this so that it is upright. I think it can probably intersect this guy if they are joined by a joint, but I'm not sure. And then we'll make that the parent, and we'll create another one, and we'll create yet another one. Oh, I missed that a little bit. It doesn't matter. And now we have this beautiful hierarchy going on here. Where are we at? Was gone for a few hours. You arrive right when it's potentially getting interesting. So we have this thing now where we can create these dynamic objects. We can, at least in theory, query their parent, and we should be able to have sort of like a hierarchy of joints here that we can hopefully then break. That's my hoping, at least. Alright, so what happens now if I just run this? Actually, what will happen is that they will just fall because I haven't toggled this thing. So here you can see now we have this create joint to parent. And if we toggle this on, we also get this break force and break torque there. But let's not do that yet. Let's see if we can actually just get these joints to work. Alright, and we need to load this. So let's load breakables. Oh no. Component context 402. Okay. Let's see what's going on. 402. Get physics actor. Interesting. So what happens here is, for some reason, we can't find a physics actor from a parent. And I wonder if that is somehow because... well, I don't know why that is. Let's see if we can figure out why that is. So let's run it here in the debugger. Yeah, the joints should already be set up to support braking. Right. Yeah, clearly something is not. What we're seeing here is the client side. The server assert failed. Let's see what's going on. All right, we have a parent. Okay. Parent name hash is some number. Physics actor. Huh, that's interesting. Why don't we actually get an actor out of that? Get physics actor. Okay, what is T? T is a dynamic body transform component. That's good. Yep. Oh. What? So we actually got something, but then we somehow returned the wrong return value. That's strange. Or is the actor here actually? Okay, it's null. PTC. Variables optimized the way not available. That's annoying. I'm kind of thinking that's probably not actually the case, but let's go into Visual Studio. I'm gonna unload this guy. So this would be Zig physics bindings. Let's do basis optimize off here so that we don't optimize away anything that we might want to. Oh, it's actually not in this file, it's in the main file. It's in Zig interop. Get physics actor. Yeah, it's not. Is it that one? Yeah, it's this one. Isn't it? No, it's context physics actor. Ah. Does that mean that that we actually can find our own physics actor? Kind of suggests that is the thing. That would be stupid. What is this? Elevator car, okay. Yeah, elevator car again. And again. Monorail car. Player 0. Right, I haven't even loaded those, but now I have. So now the object is static beam, dynamic beam. And that actor is 0. That's because this physics transform component is 0. What? What? You can see here, even in this debugger, that is a physics transform component. So, what? Dynamic body transform component is a physics body transform component. right? This guy is a physics transform component, so why does the cast to physics transform component fail? Okay, actually it doesn't fail, but the physics actor fails. Okay, okay, yes. I know why this happens. I know why this happens. And it has to do with the... Oh, let's not do that. Let's not get rid of too much. That is a good state to be in. It has to do with the creation that I mentioned briefly previously. The fact that we have this create here, and we also have the other function that we can use, which is called on-game object created, right? Let's verify that that is the name of it. On object created. That's the signature for it. So we want to create it in this one instead. I guess we can do like, you can get all of that done there, but we want to do this one in the rest of this in the on object created. Take those away from there and take that away from there. Now this should work, because if you go and look at the dynamic body transform component on object created, this is where it actually creates the physics objects. And create is called before on object created. So I think this is what we actually want. Let's see. Let's see if it is. Okay, so we do get the transform now, but it's apparently not yet quite working, because they still fall down, right? So we can probably drive on those guys, but we might not be able to. Actually, maybe we don't. Let's see. Yeah, so that's set to default. Default ground is what we want to have it. I set it on the static beam, but not on the other ones. Okay, good. Good. Okay. All right. Well, yeah, that still doesn't explain why they fall down. I should really put this, what is called load breakables. Let's put it here into this server. Run dev script, so then I can run this faster. Oh, deb script. Change that to V. All right, so are we actually doing all of this now? Yes. Crit fix joint. Okay. Yeah, we're doing it for a bunch of objects. Still they fall down. Now they completely disappeared. What? Yeah, physics programming, everyone. Yeah. Yeah, I wonder if this transform is somehow wrong still. Kind of thinking it probably is. Yeah, I think it actually probably is. I think this position can't be 0, because it will try to force the the centers to overlap or something. I wonder if this breakable joint is somehow being activated though, because they're falling through the world. That's why we don't see them. That wasn't the problem, but they're falling. Bye bye, and then they hit the kill plane and get destroyed. So that's not good. Actor A transform, actor B. Now that's at least one problem right there. Actor B transform. Yeah, so I had actor A there. Yeah, I'm telling you, this highlight in modern text editors is so good because you can quite easily spot your mistakes using it. Okay, yeah. So now they behave better, but they're still doing stupid things. Do we need to like set the joint as being like very sort of stiff or something? What was I had the magnet for the crane. Search for create fixed joint. Yep, that's not it. Inverse mass scale 0. That might be something we want to do. On the other hand, yeah, we shouldn't have to do that as long as the base is static. So this is basically like if you have two different dynamic objects, and you basically want one to sort of dominate the other one, then you can use this mass scale. But we have the base set to static now, so that shouldn't be necessary. It dominates it anyway. Okay, yeah, I think I know what I want here now. Basically what I want to do is have, currently they are set to both use 0, so I can have one be 0. Basically the parent can be 0, but so the B, the actor B can use 0, but the other one should have the parents transform in its local space, right? So actor B transforms actor B into world space. So if we take that and invert it, no, sorry, not that. We take actor A. Let's see. World to actor A transform. And this is like I think I have an inverse for this one, but I can turn it into a matrix, and then I can invert the matrix. Now its basis math 4.3 from orientation position. So this would be actor A transform orientation, actor A transform position, inverse, right? So that's world to actor A. Yep. And then we have can't actually declare that yet. Let's put those there below it. So then we want actor B's position in world in the local space of actor A. So actor B pos in actor A local. That would be transform point actor B transform dot position. That's a vector 3, and now we basically want to use that here. Right, does that check out? Let me know if my math is wrong here. Let's see if that works, and then I can try to explain it if it doesn't indeed work. Yeah, that works. The joint doesn't seem to quite hold currently. Not sure why that is, but it does work. The transform is now correct. Oh, you know what? You know what this is. I know what this is. Client physics and server physics. Don't forget server physics. Okay, maybe maybe it wasn't what I thought then. I thought it would be the client and server getting out of sync, because the server would be falling asleep while the client doesn't, right? If that makes sense. Right, we can't actually draw the... It is still possible that I was right. We just need to make sure that we can actually see the server physics here. Yeah, okay, so I was right. Yeah, this is sort of a nasty situation. We have two physics simulations going on. The antenna actually probably goes through those because it's only a client side thing. While these things that we are now seeing here, these are only these are physics server only things. The server side physics fall asleep, the client side physics don't. If that makes sense. So okay, I need to figure out how I want this to work, but in the meantime we can solve this quite easily by quite simply putting this only on the client instead. Actually, no, that won't work. Then we need it to be a client-only object, which we could do, I guess, if we wanted to. Needs to go away from the server. You can make client-only objects. How do I actually want this to work? Like we could make it so that it is created both on the client and the server, but then we would need to actually communicate that breakage from the server to the client, if that makes sense. And that's not something that I want to do tonight. So let's create this on the client, create that on the client, and create the transform on the client. We don't have anything on the server for this object. That's completely fine. That shouldn't be an issue at all. The static one we can create both on the client and server if you want to. There might be some strange fallout from that as well, but it should work. Let's have a look. Yes. Right. And now the antenna should also collide with that. And it does. It just the antenna is interpolated between like between sort of like a fully bouncy state and a non-bouncy state, so it doesn't necessarily match that completely. But yeah, it does actually work. Okay, so now then we should be able to take something like the mother vehicle. Hello. I forget how big you are every time. We should be able to take this and like start messing around with the crane and applying forces to it. Now we haven't actually specified any breakage forces for this yet, so it actually won't break currently. But that's really only a matter of doing that, though. Let's first see how this actually behaves. Now we have a client-only physics object interacting with. Yeah, you can see these guys go through them because the server is like, no, you're over there. The server has no idea about that whole setup there. Okay. Yeah, this turned out to be a little bit trickier than I originally thought. Yeah, you can see that on the client, like the crane doesn't actually exist at all. There are no objects showing up here. When we go to the server, we have a server representation for the whole crane. That's annoying. That's annoying. Yeah. Well, this brings another thing to mind that I should probably do. I should implement, and that is syncing of sleeping states across the network for dynamic bodies. That's not something I do currently, and it's probably something I should do. So if a body is moved around on the server, it is typically, not always, but it's typically the authoritative side. So it will communicate its transform to the client. But if it falls asleep, then it quite simply stops sending its transform to the client. And the fact that it has fallen asleep is actually not communicated to the client. They're just sort of expected currently to fall asleep at the same time, which kind of does the same thing. But that's evidently not true, especially not if you have a joint on one side of the network and not the other. So that's annoying. But another thing that we could do here, there's like 10 different solutions to this problem, but all of them are kind of work heavy. Another thing that we could do is actually synchronize the breakage of that joint across the network, because I happen to see here that breaking a joint causes a callback on constraint break. Now, this is not something that I'm actually listening to on the C++ side, but you could do something like this, and then you could actually simulate that breakage over the network. Yeah, this is tricky. Oh, it's not tricky, it's just like it's decisions. Decisions that I wasn't gonna concern myself with today, to be honest. So that's annoying. Why do I have to concern myself with these things today? Don't want to. Well, okay, so there's one other slightly easier way we can do this today. That would be by quite simply creating all of this on both sides. So client and server, client and server, and client and server, right? And like this might work in like the this might work in the 95% of the cases. What is risky with doing it like this is if so now, first of all, now we see the I don't know if you can see it because YouTube is probably compressing the hell out of this, but now we can see the highlights there, physics object on the client and on the server as well. And so now it's creating that joint on both sides, and that's fine. What is risky about this is that if we break the joint on one side, it's not communicated to the other side, and so there might be some weird glitches going on. But if we consider that that is kind of unlikely to happen, because if you apply a force on one side, a lot of the time it is also applied on the other side, then we should be able to just mess around with this, and it should kind of behave like we expect it to. So let's make that happen. Breakable joint. I have no idea what that force is. If that's a lot or small, but let's make it like 100. I think that's pretty small at least. Like so. And I think maybe we will do like one more. Something like that. We should be able to get like this thing knocked off, and if we knock it off, then it should fall. The other part should be standing still, and then if we knock off something closer to the root, oh, there we go. Hello. What did I do? What did I do? Did I do something stupid? Oh, you know what? It might be just that the breakage that force is quite simply too small. It's possible. Let's see what actually, what is like a sensible value for this. Yeah, it's still too small. Let's make it like quite a bit higher, like 5,000 maybe. Sounds like a two-parter, yeah. Yeah, maybe. Maybe. Yeah, this is kind of a tangent. It's not actually what I... Okay, well, let's make that like a whole lot larger now. See if we can get that vertical one to stand up, stand straight. This is kind of a tangent. This is not really what I'm working on right now. This is supposed to be just like a fun little test. I don't actually have any gameplay that depends on this. I just wanted to see if I can make it work. Okay, it clearly doesn't. Right, I think it's probably like the torque then that is getting oh, the torque threshold that's getting crossed or reached or whatever. Yeah, okay, so it was the torque thing. It's actually kind of interesting. Let's try that and let's see, is this now way too high again? It's the thing with these forces that you don't really know the scale. You don't know if 500 is like 1% of what you need or if it's like 50,000 times more than you need. So if I collide with this, hey, look at that, and then it kind of goes crazy a little bit and then falls through the ground. All right, cool. So we should maybe make that the default one then. Luckily, if we now duplicate this, we should get the same values. If I duplicate this guy like this, it should be all good. Oh, we get the same. Oh, okay, I didn't realize that's what you get, but that is true. Get rid of those, maybe. Actually, let's not do that. Let's get rid of those, and then use these guys to test this hierarchy of ours. Maybe one more. Is that actually hitting the ground now? Yeah, it is. Okay, let's get rid of that as well. Now it's possible that the whole thing is gonna fall again because we added so much more weight onto the main one, right? Ah, it seems to hold, at least for now. Okay, let's bring in one of these. Start messing with the hierarchy. Gonna bring the camera closer here. So we saw that if we mess with the outmost one, it falls as expected. Maybe the camera wasn't in such a good place after all. Like that. So if we mess with the outmost one, we do indeed make the whole thing fall. So what if we mess with like this top one here? Probably gonna then fall, and these top ones are gonna come crashing down onto the ones below it. Ooh, it's it is. It's a little looks a little risky, this thing. Alright, so now we need to actually apply quite a bit of force on this guy. Okay. And we can apply it with this actual crane arm. Burp. Oh, there we go. Yeah, this is tricky because like we have the forces, they sort of propagate through the whole thing. So now what happened was that we actually we had the force propagate to the root one, and then the whole thing came crashing down. So we need to make this guy probably even sturdier, like that. And then we'll take like all of these guys and actually duplicate them, move them over. We don't want to do that. Yeah, that's a little tricky to keep track of. But yeah, now we have that one. That one is a very sturdy one. Let's copy that. Take those away. I'm gonna do something that I can mess with using the scout instead. So we need to sort of, oh, these need to be nested, of course. Drag that there, drag that there. Yeah, it's not as easy as I thought it would be to actually make this hierarchy, but I guess that just sort of makes sense in a way. I don't know why I thought it would be easy. Oh! Right, there was too much. So was it this one? This one actually broke off. Let's make that sturdier as well. Yeah, you can make the joints sort of stiffer, but I don't think it necessarily makes it more sturdy in this sense, in the breakage sense. Right, so if we... Oh, that's interesting. The forces sort of don't necessarily behave exactly how you expect them to. Like that thing starts just sort of swinging. Interesting. Okay, can I break this off by just driving through them? Yeah, I can. Okay, so the hierarchy does work, so that's nice. Just that some of these things are really that looks strange. And we also have the network issue to sort of contend with. The network issue might cause some strange things to happen. Boom. Yeah, I also don't know why they fall through the ground. Well, that probably has something to do with the joint. So one thing to learn from all of this is that if we do these kinds of breakable joints, because this is the first breakable joint I've ever done, if we do these breakable joints, we will definitely want to listen to the on-constraint broken, or whatever it was called, and actually remove the joint completely, so that it doesn't do any sort of filtering by object reference, such as falling through the ground here. If a joint gets broken, we want to remove it completely, not keep it around. There was something about it here in this Yeah. Breaking a joint generates a simulation event, and the joint no longer partakes in simulation. So on joint break. Yeah, so there's on joint break and there's on constraint break. Okay, well, one of them. And the joint no longer partakes in simulation, although it remains attached to its actors until it is deleted. And joints being attached to actors actually affects filtering, and that's probably why they fall through the ground. Because of some side effect of something related to the filtering. Okay, well, now we know that. Yeah, it's safe to say that this wasn't necessarily the resounding success I hoped it would be on the physics side. However, we did quite a lot of really good tech work today, because I finally got that hierarchy exposed to Zig, so that was good. Also, I wonder if the one reason why they're sort of wonky, these joints now, is because we attach we have the joint be sort of placed at the parent. Like this guy is technically attached in the middle of this guy, right? And this guy is technically attached in the middle of this guy. That's the math that we did, like this whole thing. Yeah. So I might have to actually look at, if I want to do something like this, I might have to look at being able to specify where that actor is supposed to be, or that joint is supposed to be sort of positioned in the world. The reason I didn't do it now was that I figured I could just do it through this hierarchy here. But it's not necessarily enough to be able to do it like that. So, I guess we'll see. Yeah, alright. Let's get rid of this thing. Cool. I think we're pretty much done for today. This was sort of a sidetrack thing. Like I said, I will continue with the audio work. Let's turn off the music for a little while. So like I mentioned in the beginning of the stream, this has been a pretty long stream actually. We now have impact sounds, but only for the vehicles. So this is starting to sound kind of okay, I guess. Some of the sounds are actually very subtle. Of course, we have the slipping sound here, and then we have some sounds when we are actually just driving over bumps and things. And so this is starting to be kind of fun, but just driving with nudging your chassis into something doesn't produce any sound yet. Quite often actually, if you drive into a rock, for example, it will produce a sound because the suspension gets compressed. But yeah, just generic sort of impact sounds. So if I drive into here, you can hear like a boom, but that's actually because the suspension gets compressed, not because the chassis was hitting something. So yeah, I need to continue with that, and then I have a bunch of just sort of one-off sounds for various things that happen here in the game world to take care of. And then of course all the mother vehicle sounds are still missing. Great stream. Well, thank you. I'm glad if it was enjoyable for someone. It was a little it got a little rambly at times. That's typically how it tends to go. So yeah, there you can hear for example that if I land on my roof with this car, there's no sound because the chassis is an actual rigid body, and I don't have sounds for that yet, or I do, but they don't work terribly well, so I'm disabled for now. But yeah, that's where I'm at. More audio work. It's a little slow. That's mostly because I'm so inexperienced with doing audio design and all of that, but I'm getting better at it all the time, so that's at least something. Anyway, thanks for hanging out today. Hope to see you in upcoming streams. Be sure to leave a like, subscribe, do all the YouTube jazz.